As our global population grows and climate change intensifies, achieving food security and sustainability of our food system is becoming more and more important. These challenges are integral to our global efforts to achieve food security, aligning with the United Nations Sustainable Development Goals to end hunger, ensure access to nutritious food, and promote sustainable agriculture, all in pursuit of a food-resilient world.
For a small city-state like Singapore, food security and building more sustainable, resilient food systems for production and processing of nutritious and affordable foods is crucial. Currently, over 90% of Singapore's nutritional needs are met through imports. Yet only 1% of land is available for traditional farming. To sustainably produce 30% of our national needs locally by 2030, we need to develop innovative approaches.
To support Singapore in establishing more sustainable, resilient food systems, we launched the Urban Microalgae Protein Project at the Singapore-ETH Centre in 2022, where we partner with Swiss, Singaporean, academic and industry partners, as well as governmental agencies. Our goal is to develop affordable, nutritious, protein-rich foods that meet consumer preferences to move us one step closer to a more sustainable food system and ensured food security. We focus on food production and processing, working with yellow microalgae, tiny single-celled organisms. Why? Because they're nutritionally rich and they can be grown in urban environments, making them ideal for Singapore's limited arable land. This is our journey and what we have accomplished as a team.
At the National University of Singapore's Department of Food Science and Technology, we cultivate protein-rich yellow microalgae through a circular bioeconomy approach. Here, expensive and non-renewable substrates are completely replaced with brewer-spent grain and soy-whey hydrolysates, without compromising process performance and demonstrating comparable production costs. This has never been achieved in previous scientific endeavors.
We at the Biotransformation Department of the Singapore Institute of Food and Biotechnology Innovation have developed a robust microalgae bioprocess that delivers a nutrient-rich biomass ingredient perfect for the alternative protein market. Our process not only ensures high quality, but also excellent yields.
As you can see, we have successfully scaled up production to 200 liters using our pilot-scale fermentation facilities. We are collaborating with partners both locally and globally, empowering them to create the next generation of innovative ingredients and food prototypes.
Due to their high nutrient content and rapid growth rates, microalgae are an outstanding food choice, but their economic viability is currently limited by inefficient production and processing. Our project addresses this challenge by boosting the productivity of Auxenochlorella prototicoides microalgae using the Stellar Gemini Bueller machine. Moreover, whole microalgae is not always ideal for every food product. Therefore, we extract the microalgae protein using microsecond pulse electric fields. This energy-efficient technology is typically better than other traditional industrial extraction processes. Now, the real question is, what are we going to do with this protein next?
At the NUS Department of Food Science and Technology, we have developed hybrid seafood analogs based on macroalgae, as they have multiple advantages. Using macroalgae as an ingredient could improve nutrition, palatability, and sustainability. Further, seafood is a key Singaporean staple of relatively high value. Lastly, few alternative seafood are currently on the market that have a comparable nutritional value to the real seafood. Using a process called extrusion, we could successfully mimic a fish using macroalgae and soy protein.
We also use 3D footprinting technology to collect macroalgae-based seafood analogs. We developed a mock calamari ring using high-protein ink derived from macroalgae and mung bean sources. The rings are ideal for people allergic to mollusks.
We've seen how microalgae are produced, and we know it is a sustainable food option, but how would Singaporeans respond to microalgae-based food products? My portion of the study investigates how open Singaporean consumers are to microalgae-based food products and to identify which types might appeal to local preferences. The goal is to create products that truly resonate with local taste buds. For the study so far, we found out that vegetarian products are the most aligned with consumer expectations. The most receptive group consists of young, high-income men who are health-conscious, environmentally aware, concerned about social image, and willing to try new foods. Microalgae-based foods are currently perceived as less tasty compared to other options. This is why improving their sensory appeal and texture is crucial for successful commercialization. In partnership with NUS, I gather consumer feedback via sensory studies to aid in refining taste and texture of the prototypes. This could mark the start of a new food innovation tailored specifically for Singaporeans.
In addressing food security and sustainability, we believe that microalgae-based products offer promising solutions. Using advanced technologies and consumer insights, we hope to pave the way for more nutritious and environmentally friendly microalgae-based products that can become one day a staple in your culinary landscape.